Let's discuss a 3.3 geometric sequence. Um, Let me write a sequence first. 3, 6, 12, 24, 3 dots. And first of all, we need to know that the way of identifying whether a sequence is a geometric sequence or not. Assume that if we are thinking about this direction, so we can find a series, whether it's a geometric sequence or not, by taking any term and divide uh, from the previous term, and we have to do this testing for at least one or two pairs, and then we have to compare the quotient. We can select any term 12 and divide by previous term 6, and then again we can select any other term and divide it by its previous term, and we are comparing this quotient, and we know this is 2 and we know this is 2. If this quotient is same, it means that that series sequence is a geometric sequence. If you want to go to this direction starting from here, then what you have to do, you have to take any term, let's say 6, then you have to divide it by the next term, and we have to follow the same thing to other pair. So I'll take 12 and divide by 24. So this is half, and 12 over 24 half. So by looking at any direction, by taking this quotient in any direction, uh, we can determine whether this is a geometric sequence or not. So this is half and this is half, so they are equal. Then this is a geometric uh, sequence. So since this is confusing in this way, so what we can do, we can write this one 24, 12 and 6 and 3 to the same direction. 24, 12, 6 and 3, and we can use the same direction instead of this one. So basically uh, take any term and divide it by previous term 24, and take any term 6 and divide it by previous term. So this is half and this is half. So if we want to go to this direction, instead of going backward, we rewrite the descending order, and we can use the same uh, general procedure, which is divide any term by its previous term. So in simply, what you need to know that if you want to find a sequence, whether it is a geometric sequence or not, you just take any term and divide it by previous term and get the quotient value, and then see the quotient, and then 12 divided by 6 and get the quotient, or you can tell the ratio as well, and then check whether those ratios are equal. Then this is a geometric series. Let's write above sequence is a geometric sequence as 6 divided by 3 equal 12 divided by 6 equal to, or 6 divided by 3 equal to, equal 12 divided by 6. So we can write anyway. So we refer this value as a common ratio. We refer this value as common ratio. Let's take this as r, then r value is 2. And we know that this is the first term, a equals 3. Now, how do we write the other terms of this geometric sequence? So we can write like this. First of all, 2 0, 2 1, 2 2, 2 3, 2 4, 2 5, like dot dot dot. We can extend, and then we have to write, multiply this term by the first term. So 2 to the power 0 is 1. 1 times 3 is 3. 2 to the power 1 is 3. 2 to the power 1 is 2. 2 times 3 is 6. And 2 square is 4. 4 times 3, 12. And this is 8 times 24. And this is 16 times 3, 48. So likewise. Another example. The common ratio is 3 and starting value is 4. So how do we write the sequence? So this is the ratio 3 0, 3 1, 3 2, 3 3, 3 4. Likewise, then we have to multiply by first term. So 3 to the power 0 is 1, so this is 4, and this is 12, and this is 3 square, 9 times 4, 36, and this is 27 times 4, 108, and this is 27, 81 times 4, 324. Likewise. My next question is, this is first term, second term, third term, fourth term, fifth term. How do you write 18th term? So this is first term, this is second term, this is third term, fourth, fifth. Now we can see that the 18th term, the all terms should have 4. There is no argument on this, 4. Then the ratio, and we need to find the power. So what is the power? Now we can see that if the term is 1, then the ratio is 1 less than. If the term is 2, sorry, the power is 1 less than the term 2 minus 1. And if third term, the power is 1 less than 3 minus 1, 2. And the fourth term, the power should be 4 minus 1, 3. Fifth term, you can get 5 minus 1, which is 4. Now I need 18th term, term 18. So then the 18 minus 1, that is 17. Another one, 99 term. So we can write 99 term, T99 term 99. So we need the first one, and then we need the ratio, and 1 less than the term, that is 99 minus 1, that is 98. So likewise we need nth term. So nth term we can write, we need 4 as it is, we need 3 the ratio, and then 1 minus this one, so n minus 1. Let's discuss another example. 2, 6, 8, 54. So we'll check whether this is a sequence, geometric sequence. 2, 6, 18, 54. So any term divided by the previous term equal 18 divided by 6. Hence this is a geometric sequence. So the R is 3. So R is 3, and the A equal 3. A equal 2. Now I want to write the let's say 20th term, T20. So with our knowledge we know now, we need the first term, and we need the common ratio, and then 1 less than this number, 20 minus 1. So 2 times 3, 19. So this is the 20th term. If we need nth term, then first term is we need, and the ratio we need, and we have to decide the power. So 1 less than the term. So 2 times 3, n minus 1. I need alpha term. 2 times 3, 1 less than alpha, alpha minus 1, which is yeah, I rewrite this one. How do you write these terms? 150, 170, 174, and let's say 202, 150 terms, 174 terms, 202. So we need the first term, always 2. We need the common ratio, that is 3. And now we have to decide the power. Power is 1 less than 150 minus 1, 149. 174 minus 1, 173. And 202 minus 1, 201. Now we'll try to write the geometric sequence in general. Assume the first term is A, and the common ratio is R, then you know how to write now the sequence. So we start with the common ratio R0, R1, R2, R3, R4, likewise, and then multiply by A. R0 is, we know that that is 1. So AR, AR square, AR cube, and AR 4. And if we want to turn this sequence, this geometric sequence into this, then we know that A is 3, or the first term is 3, and the ratio is 2. So basically we can write 2, 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, and multiply by 3. So this is 3, and this is 6, and this is 18, and this is 54, and this is I think I did erroneously, because A is 2 and R is 3, so then this is wrong. Then ratio 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, and the first term is 2, so this is going to be 2, this is 6, and 9 times 2, 18, and 27 times 54, then 81 times 2, 162, likewise. So this sequence we can write in this form. Let's discuss example 8 in the book. Example 8, we have to write the 10th term and nth term of this sequence and another sequence. So what is the 10th term? So term 10 is, we know that we need the first term and we need the common ratio. Actually, we'll find the common ratio first. 6 divided by 3 equal 12 divided by 6 equal 2. So the common ratio is 2. So first term is 3 and we need 10th term. So T10 equal first term times the common ratio and 1 less than this value, 10 minus 1. So 3 times 2 to the power 9. And we need the nth term, Tn. Again we need the first term and then the ratio and 1 less than this one. The next one is part B. 40 minus 20, 10 and minus 5 dot dot. We'll find the common ratio. Common ratio is minus 20 divided by 40 equal 10 divided by minus 20 equal minus half. So common ratio is minus half, and First term, first term is 40. Now we need to write 10th term. So t 10th, we need first term, and then we need the ratio is minus half. So we have to put a bracket, all it is minus, and 1 less than uh, the term. So 40 minus half to the power 9, and 40. So this minus 1 you can bring up or down. So I will leave at minus 1 as it is. So minus 1 to the power 9 and 2 to the power 9. And now 40 minus 1 to the power minus 1 to the power 1 is minus 1, minus 1 to the power square is 1, and minus power cube is minus 1. This is alternate with 1 and minus 1. So if the power is odd, then it is minus 1. So minus to the power 9 is negative. So then we can write minus 40 over 2 to the power 9. On the book I can see 2 to the power 9 is 512, and then we can simplify this one to minus 5 over 64. Let's write the nth term for this one. So a is 40 and the common ratio is minus half, and we need the nth term. So we need the first term times common ratio and 1 less than this one. And so 40, and this is you can bring this minus 1 if you want to the denominator, or if you want to the numerator, but it is easy to work with minus 1. So I will leave as it is. So minus 1 to the power n minus 1, and divide by 2 to the power n minus 1. Then I can bring this one to front, minus 1 to the power n minus 1. So according to the odd and even, this is become positive and negative, and the remaining 40 over 2 to the power n minus 1. So the way we can simplify, if I can write in terms 40 in terms of 2. So 40 in terms of 2, 10, 5. So 2 to the power 3 times 5. So we can write minus 1 to the power n minus 1, 2 to the power 3 times 5 over 2 to the power n minus 1. I can bring this 2 to the power n up. That is going to be um, minus 1 n minus 1, 2 to the power 3, and this value become negative value times 5. So n minus 1, 2 to the power 3 times 2 to the power minus n plus 1. I expand with minus 1 times 5. So actually I'll bring 5 to the front. 5 minus, okay, just after this, n minus 1, 5 times 2 to the power. So we know that when the base is same, powers is addition in minus n plus 1 plus 3 minus n plus 4. So minus n plus 4. If you want, you can bring this down and keep as a numerator as well, n minus 1 uh, times 5, and bring this one down to minus n plus 4. When it is bring down, it is become minus. So we'll take the minus out. So minus times minus plus, and plus times minus minus. So you can keep in this form as well. Let's discuss example 9. In this example 9, they have given the second term uh, is 4, and fourth term T2, fourth term is given 8, and given that the common ratio is positive. So common ratio is positive. So the question is, we want to find the 11th term. So we know that T11. If we know first uh, first term, and we know the common ratio, we can write any term. So we have to use this one to find the first term and the common term. So let's assume the first term is A, and the common ratio is assume first term is A and common ratio is R. Then we can write the fourth term T4. We can write fourth term, we can write the first term times R common ratio times 1 less than this one. So AR cube. So that is given as 4. And the eighth term, we can write first term times common ratio times 8 minus 1 ER7, and given that is 8, that is 2. So we'll divide 2 divided by 1. So ER7 divided by ER3, which is 8 over 4. Then A to A cancel out. R7 minus 3 equal to, I think the fourth term is given, sorry. The fourth term is 8, so this is has to be 4. Sorry, this is, I think I messed up. So this is 2, and this is 2 minus 1, that is AR. And this is 4, this is 4 minus 1, so this is AR cube equal 8. So this is 3, and this is AR. So then this is R square equal um, is 2. So R is square root 2, positive or negative. So the common ratio is positive, so we have to take R as square root 2. Now we have to substitute to any equations, let's say from 1. So AR equal 4. So R value is square root 2 equal 4. So A equal 4 over square root 2. We can simplify this one. 4 mean 2 times 2 over square root 2, and 2 times square 2 mean square root 2 times square root 2 over square root 2, cancel out, 2 square root 2. Now we need to find the 11th term, t 11th. So we know the first term. So t 11th mean in terms of this one, AR 11 minus 1. So basically AR 10. So we found out A is 2 square root 2 and R is R to the power 10. We can substitute R is square root 2 to the power 10, or we know that R square. So then R square times to the power 5 to the power 5. So this make R to the power 10, 2 to the power 5 is 32. So we can come like this as well. So O2 square root 2, now we know this is 32. So basically 64 over square root 2. 64 times square root 2. Example 10. Example 10. 3x, first three terms of a sequence is given, x plus 6, dot dot dot. We want to find x, and then we need to find 10th term. 10th term. Now, when you look at this one, we know that there is one unknown. Hence, we need one equation. If there is one unknown, we need to have one equation to solve this one. So, what is to have an equation? So, we need something, the same thing in two different ways. Then we can equal it. The same thing, the ratio x over 3 and x plus 6 over x. So the same thing, ratio. This is also a ratio. We know that in a geometric series, they are equal, sequence, they are equal. So then we have to solve this equation to get cross multiply x square equal 3 times x plus 6. So x square plus 3x plus 18 equals 0, and x square plus, sorry, x square equal x square equal 3x plus 18, x square minus 3x minus 18 equals 0, x minus 6, x plus 3 equals 0, x equals 6 or x equal minus 3. So we have two answers, so we have to select which one. Now if x, if x equals 6, then this is 6, then sorry, first 3 and then 6, and 6 plus 6, 12, and 6 divided by 3 equal 2 and equal to 12 divided by 6, so the equal 2. So then 6 is possible. So hence 6 is possible. So x equal minus 3. So this is 3 minus 3, and then minus 3 plus 6 is 3 again. So minus 3 divided by 3, minus 1, and 3 divided by minus 3 again, minus 1, minus 1, and actually this is going to be alternating sequence, 3 minus 3. In the sum, it is given that all terms are positive. all the terms are positive. So hence we have to stay with x equals 6 uh, and as a answer, not x. So this is the, and we have to reject x equal minus 3. Now we have to write the 10th term. So T10 equal first term, which is 3, and the common ratio is 6, and 1 less than the common ratio 3, 6 to the power 9. We can simplify this one and we can give the answer. Uh, that is 3 times 512, that is 1536, the 10th term. With a small correction, is not a small, it's a big correction. So 3, we found out this is 6 and this is 12, and a equal 3, and common ratio is 6 over 3 divided by 2. So this is 2 to the power 10 minus 1. So I wrote the book answer, that is in the example this value is right, 2 to the power 9, 512. And yes, example 11, geometric sequence is given. We need to find the first term to exceed the 1 million. So 3, 6, 12, 24, and let's say some term, some numbers, let's say that is m term, so that is less than 1 million. This is less than 1 million, and the next term, let's say n term, this n term is more than 1 million. And after that, all the terms, let's say n plus 1 terms, they are more than 1 million. So this is the boundary. The just one before n, which is m, or we'll write n minus 1, is less than 1 million, the size. And this one more than 1 million, this term, let's say alpha, and this is beta. So this is alpha term is less than 10 million, 1 million, and beta term is more than 1 million. So we need to find this beta mm, beta term, which is n, which term number. So we'll write uh, what is this beta term now. This term we can write if we know the first number, first term, and the ratio. First term is 3, ratio is 6 divided by 3, 12 divided by 6 equal 2. So a equal 3, r equal 2. We need, let's assume this n terms is tn. Then 3 times common ratio times n minus 1. So now this is the beta term equal beta. So 3 times 2 to the power n minus 1 has to be greater than 1 million. Now we have to solve this one. Now this is a inequality or equation. If we have unknown term as a power, then the way we have to solve is to introduce the log. So let me write this one first. 2n minus 1 uh, divide by 3. Now we'll introduce log. So you can introduce any base basically. Log mean usually if you don't write anything 10 base, or you can get log e to the base which is ln base, and or log any base 2 base or log 5 base or any base basically. But okay, I will stay with log log base log 10. Then we have to take the other side as well. Log 10 usually we don't write the base, and log 1 2 3 4 5 6. This is 10 as well. So this is, we can write n minus 1 times log 2 equal log 10 to the power 1 1 2 3 4 5 6, 10 to the power 6 over 3. Then n minus 1 equal log 10 to the power 6 over 3 divided by log 2. Then n equal minus 1 to other side log 10 to the power 6 over 3 divided by log 2. So you can get the answer from the calculator. So n equal 19.1 plus 18.35 in the book. So that is actually n not equal, greater than. So in 19.35. So there is no term 19.35. Then the immediate one is n equal 20. So basically when n equal 20, the term 20, this geometric sequence, when n equal 20, the term size is more than 1 million. And 1 before 9, n minus 1, 20 minus 1, 19, it is less than 1 million. And all these terms are greater than 1 million. So as experiment you can do, instead of 10, so you can work with ln, or just work with different base. Log 7 base, then you have to work with 7 base until n. But still the answer is same. Just about the base, um, 10 base 10, it means 0 1 2 3 4 5 6 7 8 9. So 9 numbers. If it is base 9, 0 1 2 3 4 5 6 7 8, 9 numbers, 0 to 8. Likewise base 4, 0 1 2 3, 4 numbers, 0 to 3. And let's say base 2 is 2 numbers, 0 and 1. And any base number. So if I write usually 1, 2, 3, so we refer 123, but usually we write base. We know this is base 10, but it is possible it can be in any base up to base 4. It can be 10 base, it can be 9 base because 3, 1, 2, 3 there, and it can be base 4, but it can't be base 3 because base 3 means 0, 1, and 2 because there are 3 is here. This is simple idea, and basically we can turn any number to the any base basically.